Stuff back. All right, here we go. So everything we've talked about in this chapter has been about arcs and angle measures, and now we're going to change things 180 degrees today and start talking about segment lengths. This is going to cause some confusion. Like for instance, on the next quiz, I'm going to ask you for a segment length, and you're going to tell me that segment is 37 degrees. Okay, and I will throw my head back and laugh. And then mark it wrong. Okay. So you got to be careful to determine if we're looking for segment lengths or we're looking for arc or angle measures. Some of the rules still apply. We're still going to ask, where's the vertex? We're still going to have some rules in place to handle that. But again, we're looking for the lengths of segments. So here's the first one, the Chord-Chord Theorem. This picture looks familiar, does it not? We just did it yesterday where we would find the angle measure here, for instance, and use that to determine the arc measures, or use the arc measures to determine the angle measures. We're not doing any of that. We're talking about lengths now. Left chunk times right chunk. So look up here for a second. Left chunk times right chunk equals left chunk times right chunk. So you take the chord, you split it into two parts. They're not halves, they're just chunks. Multiply the two chunks together, it has to equal the other two chunks from the other chord. Yes, sir?
Does it matter which two sets of chunks you start with?
I'm not sure I understand what you're saying.
Does it matter if you start with IR and RE instead of TR and RG?
Oh, no.
Does it matter which?
No. A times B equals B times A.
Alright.
So you could do RE times IR equals TR times R. Yeah, it's a, you know, yeah. Yes, sir?
So if we were given ER and RG, we could set those equal, right?
No.
That means
No. Because they don't have to be. Think about, I could take that little guy and shove it way up there in the corner, so one chord is really short, the other one's big and honking. Okay. Anything else? Okay. Right? Right?
Wait.
What are you doing? Drawing a picture of the tiger? Nick, you look like you hurt yourself. What's the matter?
I am hurt. Oh no. Never mind.
Okay, fastest recovery ever.
I didn't know the formula with the letters.
I understand. Going back to some, this is new terminology actually, so as we start to talk about segments, this MN and ME, so from a point outside the circle, through the circle to the other side, that's called a secant segment. So I take the secant, which is the line, and I chop off part of it to get the secant segment. You with me so far? So this is a secant segment, MN. MO is called the external secant segment. So if this is the external secant segment, what's ON called?
Internal.
No, it's a chord.
Yeah.
It's it every time, suckers. You were there though, weren't you, Jack? Yeah. Okay. Where's the vertex? Money. Good. What do you say about it? There's a K there.
There's always a word in
Yeah.
your shapes.
Yeah.
Like
Monkey.
3 lessons, it was just.
Oh.
That's why there's a picture of a monkey.
Mr. Idiot's a potassium.
Oh, that's right.
It's been animals for like.
Hold on a second, I can't let this one go.
Money.
No.
Yeah, tiger.
Did everybody realize why this guy was in the corner?
Yeah.
And do you see the word tiger up here?
Yes.
Okay.
Oh, I did not.
Just want to make sure we're all on the same page. Now, do you understand why there's a picture of a monkey here?
Now I do.
Money.
Monkey.
Money.
I don't want to mention any names,
Money.
but someone was just sitting there going, money! Hey, there's always words in your pictures. Notice I didn't mention any names, so you're safe when this is, if it is actually recording, then you won't be humiliated.
Mr. Reedy, could you say potassium to the middle?
I'm sorry,
Nicholas
what?
Ergasto was definitely safe.
Potassium to the middle.
Yeah, it's potassium money. That's what it, I actually
Potassium.
just couldn't find a picture of potassium.
Potassium.
Wow, that was nerdy.
That's why it's
Okay, so if we take that setup, now that we know the terminology, we then have a theorem that goes along with that. which is this guy, secant segment theorem. Actually kind of fun to say.
We just write that in other
No,
words.
no.
You can do whatever you like, Sam, this is America.
Five power right now.
Thank you.
Oh,
I would recommend just the stuff in blue. If you're gonna write that whole paragraph, write like a mad person or get it later, because I don't have time to wait. Most commonly missed thing in this section is the following. In the last picture, we did left chunk times right chunk equals left chunk times right chunk. So people want to transpose that into this picture, but notice the rule. It's the outside times the whole. So it's the external secant segment times the secant segment, not the external secant segment times the chord. Pregunta.
So with these theorems, what are we trying to find?
Segment lengths.
Okay.
You'll see in a second. I'll get to some examples and you'll start to see the big picture. The tree through the forest. No, the forest through the trees? Which one is it? The trees through the forest.
I mean, horse trees.
Okay, so what happens, there's another theorem coming up on the next slide, but let's talk about where that comes from. What happens if I start to slide n counterclockwise? Go ahead.
Wait, just the chord gets smaller and the external segment gets longer. That's what you want to know or not?
I can? Thank you. Appreciate it. I'm sorry, what did you say? I was waiting.
I said that.
Yes.
Oh.
That's the worst part is when you don't recognize you said it.
Okay.
What was your statement? I was waiting.
The chord ON gets when it gets smaller,
Uh-huh.
and the segment MO gets longer.
Okay. So I got a little picture of that.
Should put a GIF.
Like GIF.
A GIF.
No GIF.
What GIF? Jiffy.
Oh, GIF. Would it start or stop recording?
Wait, how
then?
come this
this
one's not
doesn't
No, I don't
labeled?
think so. It doesn't full screen record,
Yeah,
so
this
it should
one's just
record
A,
this.
B, C,
Yeah,
D,
it
E,
should.
F.
Okay, so same setup. And notice here's the theorem in place. So I took AB, which is up here, times AC, the whole thing, and I got a number, 116.94. And then I took AD times AE, multiplied them together, completely different numbers, got the same answer. Yeah, I know, it's amazing, isn't it? As I move one of those things, let's suppose I move E over there, you'll see the numbers change, but the values stay the same. It's recalculating these numbers over and over again. It just happens to stay the same. Now what happens as I move C towards B? Well, like he said, the chord gets shorter, the external secant segment gets longer until eventually they get to the same spot. Okay. Has anything changed in the theorem? How long is the outside part? You know, outside times whole equals outside times whole. How long is the outside part for AB? 10.76. And it's not quite exact, but what is the inside part? Or sorry, what's the whole thing? Should be 10.76. I didn't quite land on the same spot. So notice as that shrinks, and this becomes, well, you tell me. Now that C goes to B, what kind of thing is AB?
A tangent.
It's a tangent, right. So as that becomes a tangent, notice that the outside and the whole become the same value. Does that make sense? The theorem hasn't changed. The outside and the whole are still the same values. It's just a little different picture. Instead of going secant, secant, we now have secant tangent. Don't save that, which gets us to that guy. If you want to write it down, it's fine. If you don't, that's okay too, because it is the exact same theorem. I just moved it over, and it became a tangent. Outside times whole, since that's the same value, equals outside times whole. Here's your first example. Solve it.
So this is the same as secant.
Mm-hmm. You might want your calculators, by the way.
Really?
depending on how good you are with quadratics. Yash, you have an answer for me?
Is it 16.67?
To be honest, I don't know, but if we wait a second, somebody else solves it, we can see if we can get a
Yeah, I confirm.
Nate's got your back.
Okay.
Check.
We'll give everybody else a second, then you can tell us how you solved it.
Why do you square AM?
Why what?
Why do you square AM?
Because this segment, AM represents the outside and the whole at the same time. So it's AM times AM.
Okay. Do all tangents?
Outside and the whole, yes.
Okay.
All right, Yash, what do you got? How'd you solve it?
10 squared equals 6x.
No.
Because it'd be 10 times 10.
That is 10 times 10, yes.
And then 6 times 6. 6 times 6.
Ooh, 6x, what are you talking about?
It would be x.
Emma, what do you got?
It would be
6 times
10 squared equals 6x times 6x times x.
Nope.
What would be 6x
Grace?
squared?
10 squared equals 6 times 6 plus x.
Nope.
Parentheses.
No, it'd be.
Nope.
It'd be 10 squared. It'd be 10.
It's-
100.
Nate, you want to fix your mistake?
Yeah.
Go.
10 squared equals x times 6 plus x.
Beautiful.
Yeah, that.
Yeah.
X times parentheses, or the quantity, x plus 6. Does everybody understand why?
Yeah.
Okay, let's go through it visually up here. 10 squared, no problem with that, right? In fact, everybody that gave me an answer had the 10 squared under control. The rule says outside times whole. How long is the outside? X. How long is the whole secant segment? X plus 6. So we get a quadratic. X squared plus 6x equals 100, so x squared plus 6x minus 100 equals 0.
Wow, these are some.
You can try factoring it, or you can plug it into your quadratic formula, and you get two answers. What are they, Rich?
I'm pretty sure I plugged it in correctly.
Go ahead.
So we got 7.44, that's rounded to 100.
Mhm.
And then we have negative 800 or 87,698 over 6,525.
Wait, I got
think that would-
7.
I must have
Wait.
plugged it in wrong.
Don't just shout things out. Raise your hand and then wait to be acknowledged.
I'm
No,
gonna
I'm not
retry
acknowledging
and
you for a
replug-
second.
I'm gonna try and
So
replug.
yours already automatically converted it to a
No,
fraction?
yours was right. Yours was
Yeah?
right.
So you don't like that fraction?
No, I do. I
What
just
is it
wanna
you don't
replug
like
it.
about that fraction?
I don't know, look too rational, but it worked.
Give me your answers again. 7.44
Hold on,
and
we got, 7.44 and negative 87,698 over 6,525.
and again, what bothers you about that second answer?
Oh, it's negative.
It's negative. There we go. And can x be negative here?
No.
No, because it represents a distance.
So
Everybody else
it's
gets, is he right? Is it 7.44?
Yeah.
Yeah. Smash.
Can I get those programs on my calculator?
Sure. What happened to the ones I gave you?
Well, my calculator died and then it lost.
Oh, yeah, that's what happens on those guys. Yes, sir. You too? All right, yeah, we can have like a little
Yeah.
file exchange problem.
I didn't do it.
How do you? Program.
I have it. Room 5.
A is.
Try to say room 5 and I said room 5.
B is 6 and C is 1. Negative. I think it's negative. Hit it again. There you go. Okay, so that's that. How are we doing for time? Oh wait, I don't know. What time are we out of here?
4 minutes.
4 minutes.
4 minutes? All right, I'll pick up the pace a little bit. 7.44, I like that. Good. Uh-huh. All right, solve that one. Depending on how well you get this, you might want to start back at square one and say, where's the vertex? It's outside the circle. Therefore, we're using secant stuff. Outside times whole equals outside times whole. If you have 8 times 18, you're doing something wrong.
Oh.
What'd you call me?
Sorry.
Jeez, no respect.
Get no respect.
Same answer for the inside part.
Oh, did it wrong. Cry.
Nope, didn't do it wrong. I lied.
Rich don't mind.
Patrick!
I got 34 and 2/3.
34 and 2/3?
No,
Uh-oh.
I got 11.
Wilma?
I got 28.6 repeating.
Yeah.
28.6. Oh, they seem to like that. What equation did you set up?
6 times equality 6 plus x equals 8 times 26.
Perfect. Outside times whole equals outside times whole. Make sure that you put this x plus 6 in parentheses because you're taking 6 times the whole thing. Gonna move on there.
What's Luigi's last name?
This is just like the one we did before, so crank this one out quickly.
I think so.
Quadratic, solve the quadratic, get your 2 answers. Nick, what word are we using here?
So you guys got 20 and 6 repeating.
I don't know.
See what I did wrong.
What's the good?
Ooh! Was it the first
It's
one?
actually a wixagoon. It's a small rodent from South America.
I
Oh,
love
not
those.
mine, look it up.
They're so cute.
They're like a,
illegal.
kind of like a combination
They have
between a
razor-sharp
mole and a mouse.
They're
They have
illegal.
6 of them in
They're
one field.
illegal in all.
I don't believe this.
They're not illegal, they're illegal to have as
Foul.
pets, they're not illegal, I mean, it's not illegal to be a wixagoon in South America,
There's
it's
no
illegal to
foul.
keep them as a pet.
Look it up on your cover.
There's no help.
Look how it's going.
You can get them sometimes on the black market because they make them into decorative lamps.
Think I got it, but
Lambs?
Really?
Yeah.
Actually?
Yeah, yeah, they stuff them and they make them into lamps, so they're like, and they got a lamp coming out of their head.
Pretty cool.
Yeah, it's pretty cool, but you don't wanna have one because you get in trouble.
Having a lamp with an animal.
I love what's
Answer,
3.39.
3.39. Hey! Example, let's go, wait, hold on. Left chunk times right chunk equals left chunk times right chunk. You would get as an answer, you don't care, but it's 1.7.
Where'd you get that?
Tomorrow, don't forget your money. You are not gonna stiff me for pies. I will have the pies ready to go when you get here. Don't forget to do your homework. We'll go over the homework quickly. I'll give you a review worksheet and then we will chow on pies.
I'm bringing skim milk. Our money is like already here.
It is.
Wait, are you bringing forks and plates? Are you bringing utensils?
Yes.